Okay, so we'll just review some of the key ideas behind logistic regression, right? So, right, we say that logistic regression is used when your response variable is binary. That means your response variable has only two outcomes, right? So, just some notation, right? Pi represents the probability of a success, that means of belonging in a certain class. And obviously 1 minus pi will be the probability of belonging in the other class. So the key term here over here will be this pi over 1 minus pi. So the probability of success over the probability of failure, which we call the odds of success. So if you look at this, odds is not the same as probability. Now, some people will say that if the probability is close to 0, right? So if pi is close to 0, then the denominator is close to 1. Then the odds is approximately the same as probability. So for rare events, right, the terms can be interchangeable. So that's odds, and if you apply the logarithm, so this is the natural log, the log to the odds, we call it the log odds of success. Now, from my experience, a lot of people tend to use odds and probability interchangeably. In my opinion, that's really shouldn't be the case, right? That can only be done if your event is rare, but some people interchange the terms. So how do we write the logistic regression equation, right? It's the log odds as this linear combination of your coefficients and your predictors. So some people will write this in matrix form, right? They'll write it as x beta, right? Where that's x is your design matrix and your beta are the coefficients, is the vector of your coefficients. So this is how most scientists write the equation. The reason why is the following: is that we like to leave the right hand side to be this linear combination of your x variables and your coefficients, right? That's just the convention in science. Now, practically speaking, right, if you want to convert it back to probability, right, because this is in terms of log odds, and most people don't really think of problems in terms of odds or log odds, but probability, you can reverse engineer equation 1, right? If you work it out, pi is basically the exponent of the linear combination over 1 plus that exponent. So you could write it that way. That's okay. So I'm going to talk a little bit about interpreting the coefficients. So I'm going to keep things simple where we only have one quantitative predictor. These are all equivalent interpretations of the slope for the predictor. And so I'm going to, instead of talking about these, I'm going to just go over some of the math here to kind of show what's happening. Right, so let's consider this situation. Right, so one predictor. Right, and so let's say the value of the predictor is x, and I'm going to call this equation 1. And let's suppose x increases by 1 unit. So what would this equation become? Right, the log, and we have new odds, right? So the pi changes. So I'm going to call that pi star to represent that pi has changed. And the right hand side becomes beta 0 plus beta 1 x plus 1, right? Because I'm increasing x by 1. So I'm going to call this equation 2. Now the next thing I'm going to do is take equation 2 minus equation 1. So on the left hand side, I get log of the new log odds minus the old log odds. And then the right hand side, the beta 0 will cancel out. And I'm left with beta 1, that's an equal sign, beta 1 x plus 1 minus beta 1 x. And if you kind of do all the expansions, this just simplifies to beta 1. All right, so the coefficient beta 1 of the slope tells us the difference in the log odds. So over here, right, for a 1 unit increase in the predictor, the log odds changes by beta 1, right? So when I increase x by 1, the log odds changes by beta 1. So that's one interpretation, right? So that's this first one over here. Now, if I do a little bit of math on this equation over here, I can combine the log terms together. Right, so this part, that is equal to that, right? So from here, I can say, well, if I take the exponent on both sides, I get x pi star 1 minus pi star over pi 1 minus pi equals to exp of beta 1. Now this term over here, this ratio of the new odds over the old odds, it's called, technically speaking, that they have a name, it's called the odds ratio. So it's basically the ratio of new odds over the old odds. So that's why we have, whoops, not that one, wrong one, let me redo that. It's basically now this third interpretation over here. Right? For a 1 unit increase in the predictor, the odds ratio is exp of beta 1. Right, so that's that third interpretation. Now if I do another step, if I multiply both sides by pi and over 1 minus pi, I get pi star 1 minus pi star equals to exp beta 1 times pi 1 minus pi. Right, so it's basically saying the new odds is equal to the old odds times exp of beta 1. So that's why I have this interpretation, right? For a 1 unit increase in the predictor, the odds are multiplied by a factor of exp of beta 1. Right? So this is the factor that we're multiplying our old odds by. And these are 3 different interpretations. They're all actually saying the same thing, right? One's in terms of log odds, one's in terms of multiplying your odds, and the other is in terms of odds ratio. So it depends on which one you prefer to think about, how you like to think about the problem. One thing to notice, right, if your slope is positive, exp of beta 1 is greater than 1, so you're multiplying by a factor of 1, greater than 1, which means the odds increase, right? So, right, if beta is positive, your odds increases. If your beta is negative, beta 1 is negative, then your odds will decrease.